There are three options for the valence electrons. Either they can be gained, lost, or shared. The rule that determines the choice of valence electrons is called the octet rule. We usually use the atomic structure to apply the octet rule. The octet rule states that, except for the first level, electrons around the nucleus tend to reach the electronic configuration of the nearest noble gas by filling each level with groups of 8 electrons. Therefore, during a chemical reaction, atoms lose, gain, or share electrons to reach the 8 electrons surrounding the nucleus. For example, the sodium atom has 11 electrons, 2 in the first level, 8 in the second level, and the third level is left with only one single electron. This electron is the sodium valence electron. For sodium atom to reach the electronic configuration of the nearest noble gas, neon, that has 10 electrons, sodium atom loses the single electron and becomes sodium ion. We also call sodium ion cation. Now, the sodium ionic configuration has 2 electrons in the first level, 8 electrons in the second level. That is why it is called the octet rule, because we have group of 8. So we expect the sodium atom to lose an electron when it gets involved in a chemical reaction. Another example, chlorine atom has 17 electrons, 2 in the first level K, followed by 8 electrons in the level L, and 7 electrons in the level M. Chlorine atom tends to gain 1 electron during the chemical reaction and becomes chlorine ion. We usually call it anion, with 2 electrons in the first level, 8 in the second one, and 8 in the third level. Notice the chlorine ion electronic configuration is similar to argon noble gas. Now moving to the third option, sharing electrons to obey the octet rule. In here you can see each oxygen atom has 2 electrons in the first level and 6 electrons in the second one. For each atom to obey octet rule, it needs 2 electrons. So 2 oxygen atoms share 2 electrons each. By that, each atom has 2 electrons in the first level and 8 electrons in the second one. During the chemical reaction, chemical bonds form between the valence electrons of the reactants to give new product. Like we said earlier, the reason behind the tendency of compounds to undergo chemical reactions and to form chemical bonds is to acquire the complete outer shell electronic configuration. In here, the reaction between oxygen gas and the carbon to form carbon dioxide. Each oxygen has 6 valence electrons and the carbon has 4 valence electrons. The 2 oxygen atoms share 2 electrons each, and the carbon atom share its 4 electrons with the 2 oxygens. Now, each atom in the carbon dioxide is surrounded by 8 electrons. There are 3 types of bonds: ionic, covalent, and polar covalent. First, the ionic bond. This type of bond forms between atoms due to the ionic interactions. During the atomic interactions, the atom loses electrons and becomes cation to an atom that gains the electrons and becomes anion. Here we have a sodium atom that reacts with a chlorine atom to form sodium chloride. The sodium atom loses an electron to the chlorine atom and the ionic bond forms. The sodium becomes a positive ion, cation, and the chlorine atom becomes chlorine ion, anion. Usually the ionic bond forms between atoms that have a difference in the electronegativity higher than 1.9. So what do we mean by electronegativity?